Hello, students. Good morning. Let me get you situated here. I hope you had a good night's sleep. Your little remote thing going on there. It is actually, take a look, 5:45, 10 to 6 now in the evening. Yeah, that's right, evening. It's Monday. I've been here all day. I know you don't appreciate it, but I have been, just for you kids. Now, AP1, here we go. This is this week's assignments. Let me see if I can get them in. There we go. Little glare there. Hey, whatever. That's the assignments this week. I'm actually wearing my mask. See, I'm following protocol. There's your assignments for the week. Okay. Come over here with me. And then we all know that we also have that lab due this week. That's what I'm going to start out this video with. Informational video. A couple of things. One, the lab due, well, it'll be tomorrow by the time you see this, where's my markers? Ay, caramba. You have a data table to make. Some people have had this question, like, I don't know how to find the weight. I don't know how to get the acceleration. What do I do? What do I do? You have a calculations table, FW and A. The FWs you get from the hanging masses. Each mass that's hanging from the string accelerated the cart a certain distance, and whatever that distance was from your group. Okay, you're going to need to know that. Make sure everybody in your group knows that. Some people have been saying, I didn't know what the distance was. They didn't tell me. Well, doggone it, communicate with your group and tell them what the distance was. Okay, now, how do I get the weight? Well, how do you get weight? FW equals mg. That's the hanging mass. So, for example, in trial 1, use 20 grams. You can't use grams, you need kilograms. So to get the weight, you take 0.02, it's 20 grams in kilograms, multiply it by 9.8, and you get FW equals 0.196. Every group, everybody across America will have that number. Okay, all right. Now, for the first one you put down, well, you didn't have any weight, you're not going to get any acceleration. You're going to need that point for your graph, that 0, 0 point. It's going to anchor your graph in, so use it. This weight here is 0.196. And then do the rest of the trials. Of course, each trial you went down 2 grams, so the next one will be 0.018 times 9.8, and put that number here. Lather, rinse, repeat. Read your shampoo bottle directions. Put those numbers in. You should have 9 or 10 weights. The weight of the hanging mass is what you need. Multiply the hanging mass in kilograms times 9.8. Okay, next. Acceleration. This is where I use F is equal to ma, right? No. All right, Bob, that's what this lab was. Yeah, but you didn't read the lab now, did you? You didn't read it. No, you didn't. What you need to do is solve for the acceleration of the cart using the third big 3. That's the square root one. AF, AI squared plus 2AD square root. You need that, solve for that. Final velocity is whatever it was in the photo gate, and you have that number. I don't know, maybe, I'm going to make a number up. Maybe it's 0.8 meters per second. So I put 0.8 here, initial velocity is 0, plus 2 times A, what you're trying to find, times your distance in meters. So if it was, and I don't know what your distance was, hopefully you do, maybe it was 60 centimeters. If that's true, then 0.6. So in my example, okay, square both sides, get rid of this, square that, this goes away, 2 times 0.6 is 1.2, divide that by 1.2. If I went too fast, rewrite and slow it down. And solve. 0.8 times 0.8 divided by 1.2, acceleration 1. You've got to do that 9 or 10 times to come up with your acceleration rates. So every single time what you do is you take VF, square it, divided by 2 times d. That gets you A. All right? All right, got it? Good. Graph this. Graph it. Graph it, graph it, graph it. You've got force, you've got acceleration, you've got a 0, 0 point. You're going to get some points. Should come out to be a relatively straight line. Draw the best fit straight line. Do the average of the points. Take the slope. Use your 0, 0 as a point. That's easy. Just pick some point where you've got the crosshairs of a graph paper on there. Read off the F, read off the A, divide, boom. Mass of the cart. Usually it comes out to be heavier than what the mass is. Some groups were using carts which were 0.2 kilograms, 200 grams, and some were using 0.3 kilograms or 300 grams. So make sure you know the mass of your cart. Do a percent error, boom. Don't forget this stuff. Data, you do have a data table. We have a graph, we got calculations with a calculation table, some error analysis, and there are some questions on, I think they're on the back of that lab, so make sure you do them. All right, that's your lab. Now, so you're going to work on that. Today, after you watch the videos on how to solve some problems. Now, I'm going to do a problem solving for you right here in this video. I'm going to upload it to YouTube and put it in the classroom for today, or tomorrow actually. I have another video which is awesome. It deals with 2 other problems, and you need to watch it. I'll load it in. Trust me. Winky, winky. That's creepy. He's winking at me. Yeah, creepy. Creepy, good. So you need to watch that video. Trust me, you're gonna watch it. You need to watch it. Now, let's do one more problem. The other day, the reason I'm doing this is I can't come in tomorrow. They're deep cleaning. Deep cleaning. Sounds like I have to go to a spa. I'm gonna get deep cleaned. That actually sounds kind of weird and awkward. Never mind. Strike that. They're going to clean everything, so I can't come into the building tomorrow, and I'm not going to be able to do this problem solving from home. So here I am on Monday evening doing this for my 2 favorite classes that I have tomorrow in Physics 1. Yeah, it's true. I'm an optimist. Okay. The other day I was doing this live for everybody. We were going through the problems, and they were able to ask me questions, which you can't do directly. So after watching the video, if you have any questions, ask. I'll be on a Zoom call at home. Okay, all right, let's dive in. Here's 2 problems. We did 3 problems the other day for my period C class. For period B and period D, you're going to get 2 of those problems in another YouTube video I have made. And I don't have my mask on in that one. I look awesome. So that one will be loaded in. We'll watch that after this one. And now there's one more problem I want to go over with you on this video. Okay. So let's say we have inclined plane. We have box on inclined plane. We have pulley at the top. There is rope attached to pulley, attached to the box. So there's a rope attached to the box over the pulley, and there's a mass here. And let's say the mass has it's 8 kilogram mass hanging here, 8 kilograms. Okay, 8 kilogram mass. This is a 10 kilogram box. So 10 kilograms. Let's see. Coefficient of friction. So there's some friction. Coefficient of friction is 0.20. Here's the question. You ready? You ready? You all ready for this? Okay. What's the acceleration of the box? What is the acceleration? Notice I didn't even say what direction. I mean, we don't know. We're going to have to figure it out. Is it going to go up the inclined plane? Is this not enough mass? Will this go down the inclined plane? Let's find out. You know what you have to do with an inclined plane problem first. You know you should do. Make the triangle. Got to make the triangle. Okay, so make the triangle. Oh, we need an angle. Let's make it 30 degrees. Makes the math easier. So if that's 30 degrees, make the triangle. You got to make the triangle. You have to. You need all sides of the triangle. That's the similar triangle to the inclined plane triangle. This angle here is 30, so this is 30. This is the force of weight side, Fw equals mg. M, 10 times g, 9.8, 98. So the weight is 98 newtons. All right, I'll write that down. Weight is 98 newtons. I need this side and this side. This is the sine side. Sine of 30 degrees equals opposite, which we're going to call Fp for that parallel force. Parallel for the P. Parallel to this surface. And that's going to equal Fp over hypotenuse 98. So if I multiply those together, I'll get Fp. Sine of 30 is 0.5, so 0.5 times 98 is 49. Multiply those, we get 49 newtons. You're going to need that. We're going to need this side as well. Do it. This is Fn. The Fn side, the normal, the perpendicular side to the incline. So that's going to be cosine. So cosine of 30 equals adjacent Fn over hypotenuse 98. So cosine of 30, 0.866 times 98 will get Fn. All right, it's going to be around 86, but let's get this. Get her down. All right. Oh, it's yelling at me. Your batteries are low, low, low. So let's see. Cosine 30 times 98. We get 84.8. We'll make it 85. Call it 85. So this comes out to be 85. So Fn is 85 newtons. Okay. So clean this up a little bit. Make some room. I've got my triangle. We got to do it. Now what? Now what do we do, Mr. G? Now what? I'm so excited. Oh, I know you are. Who was that? Was that Jackson? Yes, Jackson's excited. Let's see. Who else is out there? Chloe. Chloe's excited, yes. Oh, I can't. Who's back there? Is that? That's Tom. Yeah, Thomas. He's excited. Okay. All right. No. Oh, I'm peering. That was my period B class. Let me peer into period D. Olivia's excited. Yeah, she is. Connie's excited. Nice. Zach looking pretty excited over there. Okay. You kids are excited. I'm pumped. Actually, I'm getting pretty hungry. I need food, so I need to get her done. All right. Now what? Oh. Now we're going to look at the problem and see what we have to do. I need to find the acceleration of the box. Which way will it move? Will it move? Okay, I've got 49 newtons trying to pull it down the inclined plane. This is gravity saying, come to Papa. However, this mass up here is pulling up on the inclined plane against this down. Now, this is saying, come to Mama. This, however, is not a force, it's a mass. To get the force that's pulling down, we're going to multiply this by gravity pulling on it at 9.8 acceleration rate. So 8 times 9.8 gives me the force of weight trying to move this box up the inclined plane. So let's see what do we get. Yeah, you know, batteries are low. 8 times 9.8. 78.4 newtons. Now, 78.4 newtons is pulling down, and let me get this up here and out of the way. All right, this is Fn equals 84. Okay. So 78 newtons is trying to pull this box up the inclined plane. This is disconnected by a rope. Now gravity wants this thing down here. Now since it's connected to the rope, that force of 78 is going to be applied to that box, trying to make it move up the inclined plane. I think you can picture that. But then, this portion of gravity acting on the box from here says, nein, nein. This problem was made in Germany. 78 going up the inclined plane is greater than 49 going down the inclined plane. What's going to happen? You see it, yes you do. 78 beats 49. This is going to want to move up the inclined plane. There's more force pulling on it up than there is pulling on it down. Let's go over. Come on, take a walk. Yes, right there. Winners minus losers. Let's go ahead and set that up. We're going to need it. Winners minus losers. Okay. So F net equals winners. Get you in here. Now apparently at this point, we've got this box pulling down greater than gravity pulling it back. So you look like you're the winner. So the winner is 78.4. Minus the loser, 49. Trying to say, no, go down the incline. No, come with me. Mama and Papa are fighting here. Mama's winning. Mama wins. So minus 49. Now you might say, all right, just subtract those, and it's game over, right? Well, subtract those, get it, and we'll set that equal to MA. Problem solved. 9, remember, German problem. We have friction. Remember the friction? This wants to go up this inclined plane, but friction always helps the loser. Friction always helps the loser. You are the loser. Friction is going to help you out. Friction is nice like that, see? So we have to add friction in. Now I'm going to just erase this. We're done with it. To get it out of the way. My 49 was down the incline. There it is. So another loser is going to be, make a little room here, friction. 49 down the inclined plane and friction, who always helps the loser, are trying to stop Mama pulling down and therefore pulling this up the inclined plane. Winner, loser, plus friction. Okay, now that's going to equal to MA. All right, mass is 10. Acceleration is A. I just got to get friction and I can solve this and be done. Woohoo! We all know that FF is equal to Fn times mu. We all know that we calculated all three sides of the triangle because we're going to need them, and now we need it. We need Fn. So the friction will be equal to Fn, which we calculated to be 84, times coefficient, 0.2. So 84 times 0.2 looks like it's going to be 16.8. Friction is 16.8 newtons. Nice. That's going to help out that loser 49. We'll add that to the 49. So I'll put that here. 16.8. And now, let's solve for A. Okay, let's solve for A. I was out of the picture. Okay, so I'm erasing this. Okay. Don't do it yet, don't do it. Oh, why'd you do that? Rewind. Okay, so now let's go ahead and solve for A. So 49 is 16.8. This is 78.4 minus 59, 65.8 equals 10A. Let's do the math on this. So your batteries are low. All right, 78.4 0.4. They are getting low. I need food. Minus 65.8. And divide by 10. We get 1.26. So that is like 12 divided by 10, 1.26. So A equals 1.26 units. Important. Don't forget your units. Meters per second squared. All right. Inclined plane problem with the pulley, with a mass pulling it up the inclined plane. It's accelerating up the inclined plane. Friction helps the loser. We solved all three sides of the triangle. Why? Because we're going to need them. So just another variation in an inclined plane problem. Now, in the next video, okay, which you're going to watch, there's a problem kind of like this with an inclined plane, but I didn't have a pulley on it. We were just going to move the object up the inclined plane, and I talk about constant velocity, so please listen to that constant velocity thing. It's really important. Constant velocity means something in physics. It means the forces are balanced. You can have forces, you can have 15 forces acting on something and it not accelerating, which means constant velocity. But you still have forces acting on it. It's just not accelerating. It's important. Watch that. Now, the other part of that video is, the first part of it actually, is where you'll have an object and you're pulling on it. You end up pulling in two directions at once. That box on a nice flat table, but we're using an angle force, important. So that angle force becomes very tricky if we don't watch that video. Watch it now. Okay, so after this video, go watch those two videos. Watch that video on two more problems. That's three problems, and those are the three problems I went over last week, and I want to keep you guys at the same spot. Once you're done, if you have any questions, ask. I'll be kind of hanging around YouTube. I'm doing my work tonight, so I'll be hanging around tomorrow. Work on the lab, and that's due Wednesday. And if you've got that done, start working on these homework problems. This week, as a matter of fact, the next time we meet, which should be on Friday, it's just a work day. Because all that work over there has a lot of problems, and they're important. So at this point, we have enough on forces, on inclines and pulling on things and pushing down on things, some pulley stuff, and some friction stuff. We've got enough that we can do multiple applications, and that's what those homework sets are for. And it was also last year's quiz, which is a really good thing to know as well. So this week, from here on out, is work, get her done, problem solve. All right? Okay. All right. Now, I got to make another video for physics 2. I'm exhausted and hungry. I'm going to go home and go to bed. I'll see you guys in the morning. Okay, I can't wait. You guys are my favorites. Remember that. You're my favorites. Okay, we'll see you. Bye.